Time, why does it move only forward? Imagine you had a glass filled with water and you accidentally spill it over. A thought spontaneously would have occurred in your mind: what could if I was able to undo it? Unfortunately, as we experience in our daily lives, any such action is not permissible. What prohibits then reversing the time and going back to the original desired state? Nature, as we know of, is governed by physical laws, but at the quantum level, almost all fundamental laws are time-symmetric, that is, nothing stops events from occurring backward in time. Things just don't behave the same way in the macroscopic world, the world that you, I, and all of us are a part of. Thermodynamics comes into play. The fact that we perceive time moving in only one direction, forward, is due to the second law of thermodynamics, which plainly put, states that in any isolated system, disorder increases. That is also where the concept of entropy, or the measure of chaos, comes from. This arrow of time is a constant topic debated by physicists and philosophers alike. This thermodynamic arrow aligns with the psychological arrow of time as well as with the cosmological arrow of time. Due to the psychological arrow of time, we all perceive to have memories that run from the past to the future and not the other way around. We anticipate, plan and execute actions for the events in the future, completely unknown at that point of time, and automatically move towards it. The cosmological arrow points in the direction the universe is expanding. Without the expansion, there would be no change in entropy as per the thermodynamic arrow of time, and life as we know of, could not have existed. What is entropy after all? Let me try to explain the concept of entropy in a much simpler way. Consider your kitchen sink before you had your meal. It is perfectly clean. The system is in an ordered state, having low entropy. Now consider the situation after you've had your meal. It is full of utensils that need to be washed. What happens if you don't do anything? Well, over time, it would accumulate more dirt and dust if left as it is. The system is now in a disordered state, having a high entropy. Now if you clean the sink again, the system moves back to its ordered state. So, does this violate the second law of thermodynamics? Think for a minute or two. Well, it seems that the entropy is decreased, but the work that you had to do in cleaning the sink made you lose energy to your surrounding. This energy gained by the atoms and molecules on the microscopic scale has led to an increase in the entropy of the universe as a whole. The law is intact. So, why does entropy always increase? It is just that disorder is most likely than order. Consider one more example. Let's say you have a deck of cards arranged perfectly: spades, hearts, diamonds, and clubs in perfect order. If you shuffle the deck, the chances that the cards end up in the same perfect order are around 1 in 10 to the power of 68. So, the probability of things moving to a disordered state is much higher than ending up in an ordered state. This brings us to another question: if nature favors disorders, why did our universe begin with an ordered state in the first place? Doesn't it seem odd? This is one of the biggest unsolved questions in physics. One hypothesis is that we live in a multiverse where baby universes pop up into existence all the time. Our universe is one of the many baby universes, and could somehow start with a low entropy while the entropy of the multiverse increases as a whole. Quite similar to the kitchen sink example, where a part of the universe becomes ordered while in the rest, chaos increases. The ultimate fusion. To have a better understanding of the beginning of our universe, we need to have the two strongest pillars of physics, general relativity and quantum mechanics, come into unison. If this fusion happens, we would be better able to explain the mysteries of our universe and the arrow of time. Until then, the universe would definitely love us to spill water or coffee again and again.